On to page 2 of 7.1b, and now we're going to take what we've learned so far and use that to factor by grouping. Down here in the bottom portion of the screen, you'll see the steps. We're going to use what we know about GCF, and specifically what we've been practicing with the binomial. So we're going to take the GCF of the first two terms, we're going to take the GCF of the second two terms, and then what we'll discover is we can expect a match, and then we'll pull out that big matching GCF. So those are the basic steps. Let's see what that looks like as we go through some examples. We're going to keep our boringly good steps that we've been practicing, which means that the first thing we looked at, anytime they say factoring, whether they tell us how to do it or not, anytime they ask us to factor, we're going to ask ourselves, is there a GCF that all the terms have in common? In this case, we're looking at the x cubed, the minus 3x squared, the plus 4x, and the minus 12. Is there something that all four of them have in common? In this case, no. And you'll notice that there's not a lot of GCFs in these beginning stages of factoring by grouping. In fact, I'm pretty sure we don't really see a GCF in this. That'll come later, but again, we want to be ready for it, so we ask for it every time. The next question we ask ourselves is, how many terms are we looking at? And again, it's going to get boring for a while because we're in the section on factor by grouping, which means that we're going to see 4 terms in all these problems. So the answer is going to get old and redundant. How many terms are there? There's 4. What does that mean? Well, if there were 2, we would look for special forms. Das, doc, sock. There is nothing for sauce, S-O-S. 4 terms, we're going to factor by grouping. That's what we're learning here today. 3 terms we'll deal with next, and that's where we're going to learn how to convert it back to 4 terms so that we can use factoring by grouping. Okay, so is there GCF in all of these terms? No. How many terms are there? There's 4. We're going to factor by grouping. What are the steps? Well, think back to high school. When you went into the cafeteria, at least in my high school at the cafeteria, people kind of had their tables where they sat. And it didn't take you long to see kind of why the tables were the way they were. Certain people sat together because they had certain things in common. For example, the basketball team might sit together. The track people might sit together. The audiovisual club might sit together. The Spanish club might sit together. So there was something in common that brought them together at the same table. What was interesting is as we kind of grew through our high school years, and it especially became apparent at some of the high school reunions afterwards, is that what we thought was kind of a separation, once you got to know people a little bit more beyond their label, you really had things in common with everybody. So little life stuff happening here in this factoring by grouping. It looks like on the surface there's no GCF. There's nothing that all 4 of these have in common. However, if we pause and look at the first 2 terms, the GCF of the first 2 terms, we see that they do have something in common. In fact, it's an x squared. So we're going to pull that x squared out, leaving behind an x minus 3. If we were to redistribute that x squared, we'd be back to the x cubed minus 3x squared. So we divide both pieces by the x squared, the GCF, leaving behind an x and a minus 3. And then you look at the GCF of the second 2 terms. So it's kind of like you have the basketball team over here, and of course they have this x squared, this really cool thing that they have going in common. And then over here might be the Spanish club, and also a very cool thing, they have a GCF in common too. In fact, what does 4x and minus 12 have in common? They have a 4 in common. So now we're looking for the GCF of the second 2 terms, and in this case it happens to be 4. And I'm going to bring this plus down here in the middle. And what's left behind after you divide out or undistribute that 4 is an x minus 3. If we were to redistribute the 4, you'd get 4x minus 12, because positive times negative is a negative. Okay? And so you've got the basketball team sitting together, you've got the Spanish club sitting together, and then what you realize is, oh my gosh, we thought we didn't have anything common, but when you look a little bit closer, look beneath the labels here of the basketball team and the Spanish club, we really do have some things in common. We really can connect with each other deeper than just what our labels are, the things that we do. We can connect based on who we are. Okay, that's the life lesson for today. The math lesson is, now what we see is that they have a big GCF in common, okay? And that is the x minus 3. So again, we're further along in the assignment. We're at number 66. If this isn't settling yet, go back and try some of the first part of the assignment and then come back and watch this lesson, and it'll start to make sense, because you will have been practicing this for quite a while when you get to here. Seeing that this first half, using this plus sign now, is kind of a divider. This first half has an x minus 3. The second half has a factor of x minus 3. Factor meaning it's being multiplied. That's what you pull out. So you pull out this big GCF of x minus 3, and what it leaves behind is the x squared plus 4. Now I kind of move that too far over. So the factored version so far is the x minus 3 times x squared plus 4. Now, in our and one of the things we're going to continue to look for is every time you factor, you look at what's left and see if it can go any further. This is something you want to be kind of training yourself to. X minus 3 is 2 terms, but it doesn't match any of the special forms. Das, doc, sock. X squared plus 4 is also 2 terms, but it doesn't match das, doc, or sock. It actually is an SOS. It's a sum of squares. X times x is x squared. 2 times 2 is 4. But remember, there is no formula to factor SOS. There is no way to break it down into something times something and get back to x squared plus 4. So this is done. This is factored. This is completely factored as far as it can go. Okay. Let's try number 76. Same concept here. We start by asking ourselves, is there a GCF that all 4 pieces have in common? 4x cubed minus x squared minus 12x plus 3. And I'm just going to go ahead and make these, just so I don't drop any negatives, I'm just going to make these plus a negative here. It's just one thing you can do. You don't have to, but it can help later on. And again, if you don't struggle with negatives, then don't do this. This will just make things more confusing for you. If negatives are an issue for you, this might help, okay? And if you find something else that works better for you, use that method instead, okay? So there is nothing that all 4 of these have in common. So we checked for GCF, no. Next thing we ask ourselves is how many terms? And in this case, like all the ones in this section, there's going to be 4 terms, which means that we are going to factor by grouping. And factor by grouping is the high school tables situation. We look to see what the basketball team has in common, and then we look to see what the Spanish club has in common, the 2 different tables, okay? Or you pick however you want to describe that. Maybe it's the cheerleading squad and the debate club, or maybe it's the drama team and the choir. Whatever it is, we're looking at the first 2 and then we're looking at the second 2. What do the first 2 have in common? In this case, it's going to be x squared, and you always go with the sign of the lead term here. So this is positive, so we're just going to pull out a positive x squared. And what does that leave behind? It leaves behind a 4x minus 1. Okay? When there's a minus in front of something, this was on the I can list, then it's minus 1 times x squared, or it will be on the I can list. I'm not sure which day that one shows up, but it should be soon if we haven't seen it already. Negative x squared is the same as negative 1 times x squared. So when you take out the GCF of x squared, it leaves behind that minus 1 there. Then on the second one, now here's where it comes in handy to really notice that negative. It can get lost if you leave it out in front here. So I made it plus a negative instead of minus. Same meaning here, but it just notes to us that, oh, we've got a negative sitting out front here. We need to go ahead and pull a negative. So you want to pull a negative GCF if the first term is a negative. Okay? So negative 12x plus 3, what do they both have in common? Well, they have a 3 in common, and this negative on the first term is going to tell us to pull a negative 3. So that's what we're going to pull out here. And when you divide the negative 12x by negative 3, you get a positive 4x. When you divide both the 3 by the negative 3, you get a minus 1. Now, what you'll start to notice very soon is that you can start to expect to see a match here, and that's what we have in the steps. When you take the GCF of the first two terms and then you take the GCF of the second two terms, you can expect a match. That's the whole point of factoring by grouping. If you don't get a match, there's two possibilities. One, arithmetic error when you divided out the GCF, or two, you forgot to pull that negative. If we had just pulled a positive 3 out of both, we'd end up with a negative 4x plus 1. Close, but not an exact match. So that's a reminder, oh yeah, I needed to pull the negative because the first piece of the two terms we were looking at was a negative. So there's our big GCF right here of 4x minus 1. We're looking for what now the whole thing has in common. Got rid of the labels here of the cliques, and we realize, oh, we're all just people. We do have something in common. And we pull that out, and that's a 4x minus 1 is our first factor, and then what's left behind is the x squared minus 3. Go ahead and write that separate here. And again, we just look to see what's left, see if we can go any further. And I should add that as step 4. Let's make sure I can see that on the camera. Oh yes. Step 4, we should really add, look to see if the factoring goes any further. So we're looking at these two terms. It's not a difference of squares, sum of squares, which doesn't have a formula anyway. It's not a difference of cubes or sum of cubes. The second one, here's a square and here's a difference, meaning subtraction, but 3 is not a perfect square. It'd have to be x squared minus 9 for this to go any further. So this one is done as well. When you take these four terms and factor by grouping, you get 4x minus 1 times x squared minus 3. And you can always check too. You can always check by FOIL or redistributing. Now, you want to make sure that you don't write the redistribution as your answer, because you'd be back to the beginning question. Remember, we're going in reverse. This is our done piece right here. This is our factored form. So be aware what they're asking you to do, helps you know when to stop. So take a moment and make sure these problems and these instructions and what we've talked about makes sense to you. Perhaps talk it out with somebody. Note any questions that you have. Bring those to class or your help resource. And then pause the video so you can try number 68. We'll reveal that answer in just a little bit. Okay, factored form of number 68 after doing factoring by grouping and following the steps here, you would get x plus 6 times x squared minus 2. And that is your finished version, the factored form on that.